Hi, I'm Patrick Reagan. This video, Part 5, Troubleshooting Wireless Issues, is the first of two videos that will deal with troubleshooting wireless problems. This first video discusses how to isolate and troubleshoot wireless issues by checking the basics and using the OSI model to organize what will be checked. We will then discuss various wireless-specific troubleshooting tools, site surveys, and heat maps. We also discuss troubleshooting wireless mesh networks and will introduce wireless evil twin and jamming attacks, which are cybersecurity threats. When troubleshooting wireless networking issues, you should use the following guidelines. After you confirm the problem, whereas the user is having wireless problems, gather symptoms, and determine the scope of the problem, you will start with the basics by starting with the device. Make sure wireless is enabled in the operating system and in the BIOS if applicable. Make sure the user is using the correct SSID. Make sure the user has the correct IP address and related IP configuration by using the ipconfig for Windows or ifconfig or /IPA for Linux and Mac OS. Make sure airplane mode is not turned on, which disables network connectivity. Try another device to isolate client-side versus network issue. Next, you will start with the OSI model, starting with the physical layer, and we will work our way up. Starting the physical layer, layer 1, check the following. Use Wi-Fi analyzer or OS tools to check radio signal strength or receive signal strength indicator. Look for and check for interference from microwaves, Bluetooth, and cordless phones. Check distance from access points and try moving the system closer to the access point. Look for obstructions, such as walls, metal, or other material that reduce signal. Check antenna if antennas are external. At link layer, layer 2, check to see if the SSID is broadcasting, assuming you have broadcasting turned on. Check for MAC filtering to see if the device is being blocked on the access point. Check encryption settings including wrong password or unsupported encryption such as WPA3 on an older client. Look for 802.1x authentication issues if you're using enterprise Wi-Fi. At network layer, layer 3, try to ping local hosts such as 127.0.0.1 to confirm TCP/IP is working. Try to ping the local gateway. If you're using DHCP, verify the DHCP is working properly, including if the DHCP server is up and running. Make sure you don't have a duplicate IP address. At transport and application layer, layer 4 and higher, try to ping the DNS server and make sure name resolution is working. Test HTTPS to rule out firewall or proxy issues. Check to see if captive portal is being used and the user has accepted the terms if applicable. Next, check wireless network configuration. Check for channel overlap by checking the interference with neighboring access points using a Wi-Fi analyzer. Check bandwidth settings to see if too much channel bonding may degrade performance. Check roaming thresholds that may lead to poor handoff that can cause drops between access points. Check if you have too many SSIDs, which can cause congestion. You should have 3 or fewer for 2.4 GHz and 6 or less for SSIDs per AP. Check the access point. Run access point and wireless controller diagnostics. Is the AP online and broadcasting? Check the access point and wireless controller logs for authentication failures, access point reboots, and bandwidth usage. Check for firmware updates. Check if your access point has a cap on the number of clients and if it has been reached. You may consider swapping out the access point. Perform an environment or site survey if persistent. Use AKI or NetSpot for a site survey and use Wi-Fi analyzer or acrylic Wi-Fi to check signal strength and channel. Consider relocating APs, adjusting power settings, and switching channels. Similar to wired networks, there is a limited amount of frequencies or channels and an increase in number of wireless devices. Not everyone can talk at the same time. Even nearby access points that use the same frequencies can cause interference. Most access points can monitor frequency usage and automatically move devices to unused space. In addition, a denial of service attack could include a jamming attack, which is a type of cyber attack that disrupts communication between wireless devices by sending out interfering signals. The goal is to overwhelm the target network with unwanted signals, making it difficult or impossible for legitimate users to connect and transmit data. Jamming attacks typically involve using a device to transmit strong radio frequency signals on the same frequency as the wireless network, disrupting communications. Wi-Fi scanners is a tool that detects and displays available Wi-Fi networks in the area. It will list SSIDs, BSSIDs, which is the MAC address of APs, channel, frequency band, and signal strength. It shows encryption types such as WEP, WPA2, and WPA3. It determines best channel to configure for an AP, and it identifies channel overlap, especially on the 2.4 GHz. It verifies SSID visibility. Wi-Fi Analyzers is a more advanced tool that visualizes wireless network performance and may include troubleshooting and planning features. It creates real-time signal strength graphs. It shows channel utilization and detects interference. Client tracking is shown by which devices are connected to which APs. It can perform packet captures in some cases, and advanced versions include heat maps and spectrum analysis. Spectrum Analyzers is a tool that visualizes radio frequency signals across a range of frequencies, including both Wi-Fi and non-Wi-Fi signals, to identify sources of interference in the wireless spectrum. It measures and displays the amplitude or signal strength of signals over a range of frequencies. It helps identify interference that a Wi-Fi scanner or an analyzer might miss because it's not protocol specific. It visualizes non-Wi-Fi radio frequency noise such as microwave ovens, cordless phones, Bluetooth devices, wireless cameras, and IoT traffic. A site survey is a physical assessment of a location, like a building or outdoor area, to understand its characteristics and potential impacts on wireless network performance. A site survey helps determine the best placement of wireless access points, or APs, to ensure optimum coverage and signal strength throughout the location. Site surveys involve physical observation and analysis of the environment, considering factors like building materials and constructions for walls and floors, potential interference from other devices or equipment, and obstacles that may block or weaken the wireless signals. Heat mapping tools are software that analyzes and visually represents data, often to represent or visualize wireless signal coverage. A network monitoring and logging tool is a software or hardware solution that tracks and records network traffic and activity, helping identify and troubleshoot network issues, including wireless problems. These tools collect data like bandwidth usage, packet loss, and latency, which can be analyzed to pinpoint problems like slow speeds, dropped connections, or other wireless performance issues. They provide a clear view of all devices connected to the wireless network and their activities. They continuously monitor network performance, alerting users to potential problems like high latency or packet loss. They can pinpoint which devices are causing congestion or other issues. They can help identify the root cause of slow speeds, dropped connections, or other wireless problems, allowing for faster troubleshooting and resolution. They can detect potential problems before they impact users, such as wireless access points going down or the network becoming overloaded. They can analyze logs to understand the history of network traffic and identify patterns or trends that may indicate issues. Some tools can also monitor for security threats and alerts on the wireless network. By identifying bottlenecks and other issues, these tools can help optimize wireless performance. Several tools can be used for network monitoring and logging in wireless networks, including PRTG, Nagios, Op Manager, Avik, Sabic, Datadog, Logic Monitor, and Insufficient. A wireless mesh network is a type of wireless network that uses multiple access points to create a single unified network. These APs, also known as nodes, communicate with each other wirelessly, forming a mesh of interconnected devices. This allows for a wider and more reliable coverage area compared to traditional Wi-Fi networks that rely on a single router. When troubleshooting a wireless mesh network, you need to first understand the network layout. Review mesh topology and note how many hops exist between nodes in the gateway. Check node roles on the access points to identify which are root, repeater, or leaf nodes. The root acts as the main gateway or coordinator for the mesh. The repeater forwards data between other mesh nodes, which help extend the range and robustness of the mesh. The leaf node is the end device or client that connects to a mesh but does not forward traffic. Check signal strength and quality and identify interference with your Wi-Fi analyzers and similar tools. Validate node connectivity by performing ping tests between nodes to identify packet loss or latency and hop counts. Ensure nodes aren't too many hops away. 3 to 4 max is ideal. Check if the nodes are daisy chaining excessively instead of balancing connections. If you have too many hops in a wireless mesh network, several performance and reliability issues can arise. Each hop cuts the available bandwidth often by half. This happens because each hop must receive and transmit the same data. Each additional hop introduces processing and queuing delay, which may affect real-time applications even more than data applications. More hops equals more points of failure. If a node fails, all dependent downstream nodes lose connectivity until rerouted. Mesh protocols constantly adjust routes. With many hops, routing tables change frequently, especially in dynamic environments, which can cause brief outages or route flapping. Evaluate bandwidth and throughput by using tools like iPerf, speedtest, or built-in WLC diagnostics to check throughput degradation across hops, and validate uplink bandwidth to the internet. Inspect mesh routing and protocols to make sure you don't have routing loops, unstable routes, or excessive rerouting. If using proprietary mesh topologies like Cisco RMAN and Aruba Mesh, use vendor tools to analyze routing tables. Review firmware and configuration and ensure all nodes are running the latest firmware and using standardized settings for SSIDs, channels, and Mesh ID. Set to auto-select channels or are manually configured to avoid overlap. Analyze channel usage by checking for channel congestion using a spectrum analyzer. Validate channel bonding and avoid overlap, especially in the 2.4 GHz. Consider dynamic frequency sharing channels for less crowded bandwidth, particularly at 5 GHz. Confirm each node has adequate power supply and is not overheating. If any of your access points have wired connections, check your wired connections. Restart nodes that show issues. Relocate mesh nodes for better line of sight or to reduce hops. And lastly, review logs for node disconnections, reboot cycles, and failed authentication attempts. An evil twin attack occurs when an attacker sets up a fake Wi-Fi access point, hoping that unsuspected users to connect to it instead of a legitimate network. Often, an access point is configured to look like an existing network, which could have similar SSID and captive portal or a Wi-Fi hotspot. Wireless evil twins could overpower the existing access points. When a user connects to a wireless evil twin, they could create a man-in-the-middle attack to steal data or direct users to fake sites with malicious content or to steal credentials or other confidential information. To protect against evil twin attacks, you need to use a VPN, avoid unsecure Wi-Fi networks, and stick to HTTPS websites. Enable multi-factor authentication so that if your credentials are stolen, they will not gain access without the second authentication factor. Avoid logging into private accounts such as banks, shopping, or email while connected to public Wi-Fi. If you need to use public Wi-Fi, consider using your own personal hotspot. Turn off auto connect so that you will not automatically connect to open Wi-Fi network. Question: you need to ensure that when you install some wireless access points, will cover all workstations in the office. What would you do to make sure this happens? Answer: heat map. Question: a wireless network is set up in a mesh configuration that has experienced recent growth. Some of the access points are 4 hops away in the mesh network. Users at these access points are reporting slow download speeds despite being the sole users on the access point. Which of the following would best resolve this issue? Answer: physically connect more access points. In a wireless mesh network, each additional hop between access points reduces available bandwidth due to retransmission and contention. When users are connected to APs that are 4 hops away, their data must travel through multiple wireless links, causing latency and throughput degradation. Question: a technician receives feedback that some users are experiencing high amounts of jitter while using the wireless network. While troubleshooting the network, the technician uses the ping command with the IP address of the default gateway and verifies large variations in latency. The technician thinks the issue may be interference from other networks and non-802.11 devices. Which of the following tools should the technician use to troubleshoot the issue? Answer: Spectrum Analyzer. Question: a network consultant needs to decide between running an Ethernet uplink or using the built-in 5 GHz point-to-point functionality on a wireless access point. Which of the following documents provides the best information to assist the consultant with this decision? Answer: site survey results. Question: you've gotten multiple calls that the wireless network is slow and users cannot connect to the shared folders. You checked all of the wireless access points are up. You even tried rebooting the wireless access points. You determined that the affected users are near the street at the front of the building. You soon discover that users have to enter their credentials on a web page to access the network. What is most likely the cause of the outage? Answer: someone has an evil twin access point. Since users are prompted to enter their credentials on a web page, it is most likely a fake captive portal. Question: you have gotten multiple calls that the wireless network is down and users cannot connect to it. You checked all of the wireless access points are up, and you even tried rebooting the wireless access points. Determine that the affected users are near the street at the front of the building. What is most likely the cause of the outage? Answer: someone near the front of the building is jamming the signal. For more information, visit these sites. In summary, after you confirm the problem, whereas the user is having wireless problems, gather symptoms and determine the scope of the problem, you will start with the basics by starting with the device. To help troubleshoot wireless network problems, start with the physical layer and work your way toward the application layer. Similar to wired networks, there is a limited amount of frequencies or channels and an increasing number of wireless devices. Not everyone can talk at the same time, and even nearby access points that use the same frequencies can cause interference. Wi-Fi scanners is a tool that detects and displays available Wi-Fi networks in the area, while Wi-Fi analyzers is a more advanced tool that visualizes wireless network performance and may include troubleshooting and planning features. Spectrum Analyzer is a tool that visualizes radio frequency signals across a range of frequencies, including both Wi-Fi and non-Wi-Fi signals, to identify sources of interference in the wireless spectrum. A site survey is a physical assessment of a location, like a building or outdoor area, to understand its characteristics and potential impacts on wireless network performance. Heat mapping tools are software that analyzes and visually represents data, often used to understand or visualize wireless signal coverage. A network monitoring and logging tool is a software or hardware solution that tracks and records network traffic and activity, helping identify and troubleshoot network issues, including wireless problems. An evil twin attack occurs when an attacker sets up a fake Wi-Fi access point, hoping that unsuspected users will connect to it instead of a legitimate network. Thank you for watching this video. The next video will be Wireless Networking, Part 6, Troubleshooting Common Wireless Issues. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.